Hi, I'm Luft. I'm founder and CTO of Zeugma Systems. I'm going to talk today about the delivery of video over broadband networks and the trade-offs that are needed to make this a viable option to delivering video to the home. So, in general terms, I'd say that there are three ways that people have been pursuing to deliver video. The first approach is what I'd call a real-time feed. This is very common in existing IPTV deployments. Really what's happening here is the video is actually streaming right off the network at a pace that can feed this codec without any pausing. The downsides of this approach are that there's a lot of cost in the network to make sure that this happens. If in fact the network has any problems, what you'll see is the codec start to pixelate on the television. You've probably seen that watching cable. In the second case, what I'd call partial buffering. There's a dependency on the network to deliver the video, but it stores a chunk of the movie, or whatever it is, the content. And when it's comfortable that it can withstand any fluctuations in the network, it will begin to feed this to the codec. And the idea there being that the network can continually support the video, but it may have a few variations, and that's accounted for by the buffer. The advantage here is there's some dependency on the network, but really not nearly like in the first case. The third case is more like a TiVo model. The content is being downloaded onto a hard disk drive and is essentially stored there and played from the hard disk drive. In some cases, the content can be played before it's all downloaded, but it's basically doing a calculation. Okay, it's coming down at this particular speed. I'm safe to play it now because it'll all be down by the time I play it. The downside with this approach is that it can take a long time. A high-def movie might take 8 hours to download, which really gets away from the immediacy that people desire in the first case. If you move back a little bit to the other side of the network, ultimately the goal here is that the content is being presented to that television. In the first case, where you have the real-time feed, it's pretty straightforward. The network has been engineered to receive that feed, and it will basically spew that content into that channel and away she goes. The advantage here is that the live video can also be presented here, so henceforth the use in IPTV. If I jump down to the bottom case, we have basically the trickle down. This is just a file transfer going across the network, and there's really no dependency on the network other than having some facilities in the network to move bits around. But the middle case is really the interesting one. There's a product by a company called Roku that really utilizes this second case. And what it does is it doesn't just buffer data on this side of the network. It also will run essentially a speed test across the network. And it will decide what is the sustained rate of the network. And it may choose a 4 megabit per second rate. It may choose something as low as 1.5 or half a megabit. If it's 4 megabits, you'll have a DVD quality experience. If it's less than a megabit, it'll be more like a YouTube session. So by doing a few tricks here and doing a few tricks here, the partial buffering starts to approach the type of behavior that users expect, but still there's a lag between when you start selecting something and when you can actually view it. This probably precludes the ability to do live video. Now we would argue that there's a few more tricks that can be done inside the network that aren't nearly as expensive as the IPTV solution and can accomplish almost the same behavior. That makes this middle category always be able to deliver the highest quality. The immediacy of the experience for the user can start to approach real live streaming. And we'll talk about that in another podcast.